In this lesson, we're going to talk about the mole and molar mass. We'll talk about the mole and how that quantity is used in chemistry, converting between grams and moles, and how to calculate molar mass. So what is a mole? Nope, that is not what we're talking about, not in chemistry. Official definitions that you read in a textbook are clumsy at best, and at worst, they're absolutely confusing. But here is what you need to know. A mole is a grouping, like a dozen, only the number is much larger than 12. You may have learned in a previous science course that a mole is 6.02 times 10 to the 23rd. That's a very large number, and the items that are grouped according to moles can be atoms, molecules, ions, and the reason why mole is such a large number is that these items grouped using a mole are very small. So it takes these incredibly small objects and gathers together enough of them so we can see and measure them without needing magnification. The next slide shows 1 mole of various substances: mercury, sulfur, lead, copper, magnesium, and aluminum. We see that these are amounts that can be measured and seen without any magnification. So atoms and molecules, they're too small to count by individual particles. So we measure the amounts using a balance, using their mass. But the chemical reactions that we will discuss later are described using moles. So what we have to do is convert between grams that we measure and moles that we calculate with. And that link is the atomic mass, and that's found on the periodic table. If you remember from the periodic table lecture that the atomic mass is the number below the symbol and above the name of the elements on our periodic table. So the amount of mercury that we see, 1 mole, is 200.6 grams. 1 mole of sulfur is 32.06 grams. 1 mole of copper, 63.55. And so it goes for all the elements on the periodic table. So the mathematical tool we will be converting between grams and moles a lot in chemistry. So we will use dimensional analysis. Our conversion factor between grams and moles is the atomic mass. So with all dimensional analysis problems, take your given information, apply any conversion factors, and you want to end up with your target unit. Let's work some examples. In the first one, we're given moles and we will find the mass. So how many grams are there in 2.4 moles of carbon? Our target unit is grams, and we are given 2.4 moles. So we set up our dimensional analysis array. We start with 2.4 moles of carbon, and our conversion from grams to moles is the atomic mass. So we look on the periodic table for carbon. There it is. 12.01 is our conversion between grams and moles for carbon. We put that into our dimensional analysis array. Moles go on the bottom because our target unit is grams. Set up in this way, moles cancel. We end up with grams, and we multiply both numbers on the top. 2.4 times 12.01. Please pull out your calculators and check my math. I get to 2 significant figures, 29 grams of carbon. Let's work another example where we're given mass and we will find moles. So how many moles are there in 17.6 grams of sodium? Our target unit is now moles. Moles of sodium. The symbol for sodium is Na. Set up our dimensional analysis array, start with our given information, 17.6 grams of sodium. Our conversion factor is the atomic mass. To the periodic table we go, we find sodium. Its atomic mass is 22.99. We put the 22.99 grams on the bottom because we want grams to cancel. Our target unit is moles. We want that on the top. Grams cancel. In this case, the 17.6 is divided by 22.99. My final answer is, and please double check, 0.766 moles of sodium. So how about for molecules? We can convert between grams and moles using atoms, reading right off the periodic table. The conversion factor, right there. A little more complicated for molecules, but it's not too bad. So rather than atomic mass, what we use is molecular mass or molar mass, because a molecule is not just an atom, it's a grouping of atoms. So to find the molar mass, we take the molecular formula and add together the number and types of atoms that are found in the molecular formula. Let's calculate the molar mass for water. The formula is H2O. We look at the periodic table for hydrogen and oxygen. We see hydrogen 1.008, oxygen 16. We take two hydrogens, add to that the atomic mass of one oxygen, and we get 18.02 grams of water equal 1 mole. So if we had 1 mole of water molecules, they would weigh just slightly over 18 grams. Let's work one more example by finding the molar mass for sulfuric acid, which is H2SO4. We look at the periodic table and find the atomic masses for hydrogen, sulfur, and oxygen. We add up the atomic masses for all the atoms using the correct number of atoms, giving me 2 times 1.008 plus 32.06 plus 4 times 16. Adding that up gives me 98.08 grams for 1 mole of sulfuric acid. So in this lesson, we've gone over the mole, we've talked about atomic mass, how to find it, and how to use atomic mass to find molecular mass or molar mass, and to use atomic mass to convert between grams or moles. As always, if you have questions, contact me via email. You're always welcome to come to the online office hours on Tuesday and Thursday morning. The link is right there. It's the Blackboard Collaborate Lab in our Blackboard. And you can also make an appointment if our office hour times do not work for you.